Hi, this is my lab report of Lab1 on constant velocity motion, which models the constant velocity motion of a ping pong ball rolling on a horizontal surface. So the first step is to observe the motion of some object that is moving at the same speed without changing direction. I have to capture a video of the motion. I did that. So let me show the video. So here is the video in the tracker software, and I have already selected the interesting part of the video. I actually rolled the ping pong ball down an inclined plane first so that it acquired some kinetic energy, and then on this horizontal surface it travels with that acquired kinetic energy at a constant velocity from here to here. So we can see that. So I tracked its position in each frame, and that gave me the data points like this. So I have captured the data till 0.233 seconds. Okay, so these are the x coordinate positions, and this is the time instance at those positions. And my axis has been chosen such that the origin of the axis is at the nearly the center of mass of the ping pong ball, and it's kept horizontal. And this is the positive x-axis, this is the negative x-axis, this is positive y-axis, this is negative y-axis. And so we get a graph where the velocity of the object is along the negative x-axis, so it's negative. So the slope of position time graph is negative, and its position is also negative and increasing with time. And you can see it's a straight line graph, which indicates that the velocity is constant. Okay, next I have to analyze the video to extract the object's position and corresponding time. So I did the linear fit. So let me show that. So here is the linear fit using the tracker software itself I made. So I chose the line fit. So equation is AT plus B, where A is the slope and B is the y-intercept. So y-intercept is 0. So this corresponds to the equation of motion. Final position is initial position plus velocity into time. So initial position is 0, so B is 0, and the constant velocity is A, so that is minus 0.824 meter per second. So this is what I use for modeling the motion of the ping pong ball. Next I have to construct a computational model that accurately describes my observations, and I have to explain the Python program. So here is the program. So this is where I edited it. The ball has a radius of 0.05, and the origin is at 0, 0, 0, and I entered its mass, though it's not having any relevance in this particular modeling. Then its initial position is 0 at the origin, and velocity is minus 0.824 along x-axis. Y and z coordinates are 0. Then delta t is 0.01. So I output the data in the CSV file. So the net force is 0. The time interval for the motion is the maximum time of the video, which is 0.233 seconds, and the new velocity is old velocity plus acceleration into increment in time. Acceleration is net force by mass of the ball, and net force is 0, so acceleration is 0. New position is old position plus the velocity into time, so then the time is being incremented here. Then I print out the values on the screen and in the CSV file, and these two lines will show the graph. So let me run the program and show you. So as you can see, the object moved towards the negative x-axis with the constant velocity, and this is the position versus time graph. This is the time axis and this is the position axis, and the values are exactly matching. Next I have to compare the model to my observations by plotting the observed position versus time and predicted position versus time. So here is my graph. So this is the data of the experiment taken out from the tracker software, and this is the data from the modeling which I outputted into the CSV file and copied and pasted it here. Yeah, so I plotted both the data in the same graph using spreadsheet. So the red dots are the experimental data and the blue line is the model data. As you can see, it's exactly overlapping and passing through the origin as expected. Now the main assumptions I made are that the net external force is 0 and the acceleration, as a result, acceleration is 0 and velocity is constant, and the velocity is the initial velocity throughout, and I used the slope of the linear fit of the experimental data, which is minus 0.824 meter per second, and the initial position is 0 at time t equal to 0. Now the what if question is, if I had flipped the axis, then the data values would be positive instead of negative, and because the left direction would be now considered positive, so the slope of my graph would be positive instead of negative, which means positive velocity, and that would still mean the same thing. It just says that the ball will be moving towards left with a constant speed. Then to answer the what does it mean question, though net force is 0, it doesn't mean that no forces are acting. Right now on this ball, in the horizontal direction, negligible forces are only acting because the rolling friction is considered negligible during the period of the motion which I have tracked. But in the vertical direction, the Earth's gravitational pull downwards, which is the weight of the ping pong ball, is balanced by the normal contact force exerted upwards by the floor.